Hi, today we are looking at definite integrals. So if we say if our function f is continuous on the interval a to b, then the definite integral from a to b is our integral of a to b of f of x, d of x is equal to our limit of, as n goes to infinity, of our sum starting at k equals 1 going to n of f of x subscript k times change in x, where f of x is our integrand, x is the variable of integration, b is our upper limit, and a is our lower limit. Now the symbol here is read as the integral from a to b. Now we'll look at some basic properties of definite integrals. So if we have integral from a to b of f of x, that's going to equal, I guys have an error on here. These should have been reversed on this one. So if we have integral from a to b of f of x, that's going to equal the negative integral from b to a of f of x. Now, if we have an integral from a to a, our x value is not really changing, so it's giving us 0. Now, if we have integral from a to b of a constant times our function, that's going to be equal to that constant times our integral of our function. Now we have some addition and subtraction identity. So if we have integral from a to b of f of x, where we're either adding or subtracting g of x, that's the same as our integral from a to b of f of x, and then adding or subtracting our integral from a to b of g of x. Now, if we have our integral from a to b of some function of x, d of x, that's same as our integral from a to b of that function of a different variable, which is equal to a to b of our function of a different variable. So if it's the same function but different variable, it's going to give us the same answer each time. Now, if we have an integral from a to b of f of x, that's the same as our integral from a to c of f of x plus the integral going from c to b. So as long as we're starting and ending at the same place. Okay, so some more properties of definite integrals. If f of x is equal or greater than g of x on a to b, then our integral from a to b of f of x is going to be equal or greater than the interval of a to b of g of x. Now, if our integral, if f of x is greater than 0 on that interval from a to b, then our integral will be also equal or greater than 0. Now, if f of x is between two values, m and capital M, on a to b, and m times b minus a is going to be equal or less than the integral from a to b of f of x, which is equal or less than m times b minus a. And then we have this last one, where the absolute value of our integral from a to b f of x is going to be equal or less than the integral of the absolute value of f of x, b of x. Okay, so we'll look at some examples. Given our integral from 0 to f of x gives us 7, while our integral from 5 to 7 of f of y gives us 4, and our integral from 7 to 0 of g of x gives us 5. We want to find each of the following. So we want to know what our integral from 5 to 0 of f of x is. Now, from the identities we just looked at, we can see that's the same integral as here, just opposite direction, so it'd be opposite value. So if this equals 7, we know that this is the same as our integral, negative integral from 0 to 5 f of x dx. So that's going to equal -7. Now this one we have from 8 to 8 of f of x, so it hasn't changed x value, so that's just going to equal 0. Next one, we've got our integral from 0 to 7 of f of x d of x. Now we don't have one back here that went from 0 to 7, but we do have one that goes 0 to 5 and then 5 to 7, so that will take us 0 to 7. So this would be the same as saying the integral from 0 to 5 of f of x d of x plus our integral from 5 to 7 of f of x d of x. So that's going to be 7 plus 4, which gives us 11. Now this next one is for function g. For all the ones we've dealt with have been the function f so far. Now we only had one that is function g, which was this one. We went from 7 to 0. Now is equal to 5. This one's going from 0 to 7. So we know that this is equal to our negative of 7 to 0 g of x dx. So we know that that is equal to -5. Now this one here is integral from 0 to 7 of f of x plus g of x. Now we already figured out what 0 to 7 of f of x is. That's just going to be 11. Plus our integral from 0 to 7 of g of x, so that'd be -5. And that's going to give us 6.